I find this interesting. The ancient Egyptians used parts of the eye of Horus to represent fractions. Horus was one of their gods. So while that worked for them, it doesn't work for us now. So in this episode, I'm going to show the 4 models for representing fractions in school today. And when I say fractions, I mean those that have a numerator and a denominator, which we pretty much just call common fractions. And I want you to stay to the end because I want to share an astonishing misconception that I think 1 in 5 teachers have about representing fractions. Just a heads up, in this episode I'm going to be referring to fourths rather than quarters. American teachers say fourths to avoid that confusion you might get with their money because they have quarters as coins. Australian teachers and other teachers around the world tend to say quarters. Personally, I prefer fourths because it just sounds like the number 4. Now, before I begin, I want to stress that your students or child should experience all 4 representations or models during their schooling. Each model has a different attribute that lends itself to teaching a specific idea within this big topic of fractions. Let's take a closer look. The first model that young students or your child will encounter in school is called a set model. And it's called a set model because it has a discrete countable attribute that we call quantity. These discrete objects are just concrete things that we can touch and move and share with our hands. Here I have 8 discrete countable objects. Using the sharing mat, it's quite easy to share these out equally into 4 groups. A child will soon tell you if they have not got an equal share. The difficulty comes when they have to actually unitize what's in their share. So yes, they have 2 of the 8, that's a whole number, but as a fraction, these 2 become 1. I have 1/4 of the total. And that can be really tough for young students. In any case, that is 1/4 of the whole, which in this example is 8 countable objects. I want to point out that the objects don't actually have to be the same. Here we have 4 very different objects, but because the attribute is quantity, I can still say that this is 1/4 of the set. The next model that young students will encounter is the area model. It has a continuous, unbroken, measurable attribute that we call area. And early experiences often center around paper folding because young students can pick it up, hold it in their hands, fold it, then colour equal parts. This part shows 1/4, and it is 1/4 because it is 1/4 the area of the whole. I was very, very intentional with my language then. That is 1/4 because it is 1/4 the area of the whole. I'm using the area model, therefore my language needs to match that model. The third representation is a linear model. It is a continuous, unbroken, measurable attribute that we call length. Now these can be easily mistaken for area models, but if you look at the length model, you can see that these have one-directional cuts or divisions, which allow you to measure the length of each piece in comparison to the whole. These area models have multi-directional cuts, which prohibits you from measuring the lengths. You can only measure their areas in comparison to the whole. There's a couple of nice benefits in using a length or a linear model. Firstly, they really enable you to explore fractions that are greater than one whole. And we call these fractions mixed numbers or improper fractions. Take a look at this fraction wall. 5/4 is the same as 1 and 1/4. You can't show this easily with a set model or an area model. The other benefit is being able to easily count fractions. For example, 1/4 plus 1/4 plus 1/4 is 3/4. This part-to-whole thinking is often overlooked in classroom instruction. We usually just think of fractions as being part of a whole, but that's a topic for another episode. Finally, fractions can be represented on a number line, which has a continuous, unbroken, measurable attribute that we call distance. So it's kind of a special length model. Take a look at this number line. Let's divide it into two equal parts. The distance from 0 to 1 is always one whole, regardless of how long it is or where it is in the world. This is simply an international convention. Therefore, if I was going to locate 1/4 on this model, I would have to put it here because it is 1/4 the distance from 0 to 1, which is the whole. Again, notice how my language intentionally matches the model I'm using. And this is the moment you've been waiting for. This is the common misconception I have seen when delivering professional learning with teachers all over the world. When asked to place 1/4 on a number line like this, many teachers will actually place it here, believing that this is 1/4 the length of the line. No, remember that the whole is the distance between 0 and 1, regardless of how long the line is, regardless of how many numbers you have on the line, and regardless of where you are in the world. And what are the advantages of a number line? Well, I personally think the number line is the most versatile model of all four. 1, you can use them to help us operate with fractions. 2, you can use them to show equivalent fractions. And you can use them to relate fractions to percentages and decimals. And here's what I want you to do. Remember, there are 4 models of fractions, and each model has an attribute which lends itself to different ideas within this big complex topic of fractions. And 2, when you're talking about fractions in front of your students or your child, make sure your language matches the representation you're using at that time. Don't create misconceptions by using language from a different model. And 3, after your students or child have experienced all 4 models, you can use multiple models to help them or gain a deeper understanding about fractions by making connections for themselves. And finally, if you've seen value in this episode, go ahead and subscribe right now so you never miss another learning moment with me. See you next time.